Come to the next presentation, which is by Dr. Stewart Bryant, G3YSX, using AI to write simple amateur radio applications. Large language models such as ChatGPT and Google Bard Gemini have the ability to transform the way that we write software. Using software such as these can significantly improve productivity and bring the ability to write effective software within the reach of more people. This talk provides insight into the tools and approaches Stewart used in writing a small amateur radio application, which is due to be published in the autumn 2024 edition of RadCom Plus. He hopes that this work will encourage others to experiment with these new methods of writing software. Stewart has volunteered for board roles at the RSGB since 2013, president of the RSGB from 21 to 23, currently the chair of the board. He has championed improvements in operating and technical skills in all age groups by organising and sponsoring a number of competitive amateur radio activities. His personal amateur radio activities include technology, construction and contesting, as well as travelling to better understand the international amateur radio environment. Professionally, Stewart gained a PhD in laser physics from Imperial College London. This led Stewart into a career in telecoms, where he held a number of leading research and innovation roles in the creation of new internet routing technologies. Stewart spent 4 years as routing area director at the Internet Engineering Taskforce, where he led the specification and standardisation of the Internet's routing system. He is an author of 46 Internet specifications and is an inventor of over 80 patents. Need I say more? Over to you, Stewart.
Thank you, John. So, the way I look at software is the modern soldering iron, right? It's the way we put systems together, it's the way we build new things. And what I wanted to do with this piece of work is to explore how we could use artificial intelligence to write software with less detailed knowledge. So hopefully, writing software can be more accessible to more people. So this talk would talk about something called large language models. These are sort of a thing that's really been quite hyped up since the end of last year, the beginning of this year. And a technology called generative artificial intelligence. I'm going to look at the methodology I used, because the way you go about it makes it a lot easier. I'm going to give an example, give a brief comparison of ChatGPT. ChatGPT is the one everyone knows about. It's the one that OpenAI launched with such fanfare and made available to everyone. And this forced other people to also launch their technologies. And then there's a few thoughts for the future. So generative AI is a conversational method of generating a descriptive and customized answer to a question. You see it quite a lot in these chatbots and things. And it's a hyper-fast moving subject. I make no apologies for for using such sort of hyped up words, because it is moving almost literally at the speed of light. It is every time you look at it, something has changed and it's moved forward. The one that was launched at the end of 22 is ChatGPT, and that's the one I used for most of this work. But I'm going to list just a small sample of the others. There's Bard Gemini. Bard must have been Google's internal platform they didn't discuss, and then it got launched in the hype. And Gemini is its more production version. GitHub, for those who know GitHub's a software repository system, and that has got an AI engine. I've not used it. And there's Wolfram Alpha, which is one that is more numeric in terms of what it can do. So I asked ChatGPT to talk about itself. I'm only going to use 2 of the 3 slides I asked it for various reasons, but I said to it, literally, please produce 3 slides describing how ChatGPT works and how it is different from Google Gemini. I just used the first 2 of those. And this is literally what it came back with. So ChatGPT is a large language model developed by OpenAI based on the generative pre-trained transformer. That is to say, you give it a load of text to understand and it sort of works out what that text is all about, but it doesn't properly understand it as far as I can see. It's designed to generate human-like text based on the input it receives. So how does it work? So it says, well, you pre-train it on an initial sort of diverse corpus of text data, learning to predict the next word in a sentence. So get what that means, right? It knows from when it's written a word what the probability of the next word is going to be, and I'll explain that in a bit more detail a bit later on. So after the pre-training, it's fine-tuned on other databases, and it's also fed with human feedback. So as you use it, it is learning what your reaction was, and it's incorporating that into its corpus of knowledge. And that has interesting implications later on. Improving its ability to follow instructions and generate coherent responses. And it uses inference. So when a user inputs a query, the model generates text by predicting the most likely continuation based on its training. Well, that looks fairly straightforward. So here's some key features. Remember, this is ChatGPT advertising itself. There's no, I don't know whether this is specially sort of programmed inside, but anyway, it excels in understanding and generating human-like responses, and it does. It's capable of carrying out conversations, answering questions, and providing creative context. Well, it can assist in a wide range of tasks, including coding, which is the one we're going to talk about here, writing, tutoring, and more. Although the model itself doesn't learn in real time, that is to say, it's not putting your discussion directly into the corpus of knowledge, it's keeping it, right? It's keeping it and it's feeding it in there. OpenAI frequently updates versions based on new data and free interactions. And it may generate plausible, we'll come to this in a moment, may generate plausible sounding but incorrect information. This is one of its downsides. Sometimes it struggles with complex reasoning or text retention over long conversations. This is what it's saying about itself. So how does it really work? Well, it kind of works as you say. The book I found that really explained it was Wolfram's book, which is what ChatGPT is doing and why does it do it. And this goes through, it's a very easy to read, simple book. You read it on one flight across the Atlantic. Very, very straightforward text. And it explains an earlier version of the OpenAI system and how it generates these answers from basically word association. So it constructs sentences by concatenating the statistically likely to follow word, but it applies a sort of a biological evolutionary process. It makes mistakes. You know how biology changes by sort of DNA making mistakes? It does exactly that. So it makes random mistakes from the expected next text, and it does it in a way that ChatGPT, the other one, doesn't do. All right. Now, a note of caution when you read this book. Wolfram doesn't like the idea that it's not numeric. Wolfram, of course, builds the Wolfram computer sort of mathematics system. So he's got a bit of an axe to grind in here. So, you know, take it accordingly. But it's a very interesting description of how it works. So, how do people use it? What people were doing, you see, was to take a functional specification. Functional specification is a posh sort of industry word for just tell me what you want the thing to do. So you start off saying what you want to achieve, and you have to be really pedantic with that. Then you put it through the large language model OpenAI system, and you get some code. And what people were doing was to take that code and take it as the answer. I mean, clearly it's given you the answer. What's wrong with it? Well, how many people have met Stack Overflow? Anyone who's written, you're right. So it's the first thing you get when you do a Google search for how to do something in computer engineering. What people were doing was taking the questions that get asked in Stack Overflow. It's a place where people ask questions. I want to know how to write this piece of code. And they were feeding it into ChatGPT when it first came out. And then they were taking and posting the answer. And this got people really, really annoyed because the experts on it now needed to correct the errors in ChatGPT. So for a while, Stack Overflow banned ChatGPT input into this corpus of knowledge they were building for programming. Well, the next thing that apparently that happened is that ChatGPT seemed to be putting Stack Overflow out of business because people were going to that rather than going to ChatGPT. I don't know how Stack Overflow makes its money, but they weren't going there anymore. And if you go to follow that URL, there's an interesting graph, and it does show ChatGPT comes in and their business model goes to the floor. So now they are now working together as partners from the 6th of May. Remember, the 6th of May is only 5 months after ChatGPT hit the streets mainstream. And that is just one example of where it's going in the industry. So, this is how you really have to use it. You write your specification. Be really super pedantic how you write your specification. So you don't have to know how the code's going to work, but you better be precise about what you tell it to do. You feed it into the large language model and you get some output. But you better write a test spec. You remember when you're professionally writing code, you write a test spec? Or at least you have some idea of what you want it to do. So you write a spec, test spec, and you feed that into the test system as well, and it either did the right thing or it didn't. Chances are, half the time, you screwed up the specification. And I found this in my sort of experiments, that quite often it's not doing the right thing because I didn't tell it to do the right thing. Or you made a mistake in your test, or there was something you needed to add to the test because you'd forgotten, I'd forgotten to test that. So you build a system. This is exactly the ecosystem you use when you're writing software yourself. All I have done is to start with text and put the large language model in there, treating the large language model as a text compiler. So the way I think of life is you start off with a text spec, and then you used to have to go to, originally you went to assembler, and then that got a bit boring, so you went to compilers. Nobody trusted compilers because they couldn't figure out how the assembler got generated. And now we're going to language input for a lot of modules or complete specs. Right, now it's really important that you stay in the system, because if you run this thing and you get some answers, and they may not be the answers you wanted, and you say, it's simple what I need to do, I just need this extra variable there, or I need to change this piece of code there. But as soon as you come out of the system, it doesn't know you've done it. So stay in the system, ask it to make the corrections, because as soon as you leave the system, you're on your own. So I wrote about this. I was encouraged. I mentioned it to the editor. It made me a big mistake talking to the RadCom editors. So I spoke to the and then suddenly I've got a deadline for publishing this. I'm joking, of course. So anyway, they encouraged me to write this up for RadCom Plus. And the example I use, this is why I really did it. I've got my 6400, and I wanted it to have a relay to turn it on, so I could turn it on remotely. I like to run my station remotely. And what I wanted was a bit of GUI on my PC. But I don't really know how to write Python GUI. I've never really learned how to do it. There's libraries and things you have to do, Tickle or something or other, but I didn't really know how to. So I thought, this is what got me into this experiment, you see. Why don't I just get the machine to do it for me? And I used two approaches. At the top, I used an Arduino with a relay shield on it, and the relay shield will talk to the Arduino would talk to the PC using serial. And I needed some messages to specify what I wanted to send. So the syntax was quite simple. I want relay X either on or off. And the reason it's got the hieroglyphics on either end of it is I wasn't sure what other junk I might get sent out on the serial port, so I put a bit of packet delimiting in there just to sort of screen out any spurious things. The other thing I played with was so I wanted this GUI. This was going to be written in Python. Obviously, the Arduino would be written in Arduino C, but I also wanted to try another approach. You can get these cheap Chinese relay controllers with the relays. That shows 8. I could never get 8 to work because actually it's really a whole web server in its own right. They send it to you saying you just give it this piece of HTTP here, but it turns out that you can't actually get it into a standard state. So I only ever used a 4 relay version. So you send a message to it on Ethernet, it switches the relay on. So that's what I wanted to do. So, first thing I said to it was, and this is literally what did I not? Yes, it's in Rad. Oh, I should explain that there's a lot of detail in the RadCom Plus article that I couldn't get into the slides because 24-point slides and proper code, anyone who's tried to do this will know it just doesn't go together. So this is really a video chatty sort of introduction to the RadCom Plus article. So this is literally what I said. Write Arduino code that listens to the console port for packets of the form, that rather strange syntax there, and it understood the ellipses with the on-off in it as standard notation. Where X is a relay in the range 1 to 4 and the command is on or off. If the command is set, the corresponding digital port goes to 1, otherwise to 0. If the packet is correct, reply to the console port with the packet, OK, otherwise reply with just the packet. So after a few iterations, and I mean really just sort of 3 or 4 iterations, some of which were, don't give me an edit to what you gave me before, give me the complete script, because all I want to do is cut and paste it into my target that I use using the standard Arduino IDE. It gave me about 70 lines of what I thought were functional, well commented and practical code. And if you look in the RadCom Plus article, you can see the code it gave. It really is a good code generator. So I tested it by typing commands in, which is kind of as good a way as doing it anyway, and the code really was good, and the code is in the article. So, someone can tell me how to do this better. I needed to get the Ethernet controller working. But I couldn't find a way of having it nicely paragraphed, and I think it was because the rather crude way I was using ChatGPT and the Macintosh Safari browser, it kept, every time I gave a break, it took it as an entry, which is not very helpful. So here's a simple functional spec, right? Please write a Python 3 script to read 2 parameters from the command line plus an optional third parameter. The first is the IP address, and the second is the key, which is a 0 to 635535, i.e. a 16-bit number. The third parameter specifies if debug output is to be provided. Validate the IP address and the key number. If the command line is not properly formatted, print an error with the correct format. To change the state of a relay, send an HTTP packet, not HTTPS. Took a bit of persuading to stop the thing trying to expect HTTPS. A request of the form http:// IP address key command. Remember, that was a little sort of note I had in the side, which is all you get from the chip providers. The command should create a column of 4 buttons, which controls relays 0 to 3. Get the program to open a file, button.txt, where each line is read as a CSV values, the label for the button of the command to turn the corresponding relay on, and then the command to turn the corresponding relay off, whether on Oh, and then whether the button is a toggle button or a momentary button. So toggle keeps its state momentarily, you just press it and it comes back on you. The button text for all buttons is initially green and the relays are all off. When a relay is off, the button text goes green, and when it's on, it goes red. Continues a bit. When a button that is green is pressed, then the corresponding HTTP request turns to green, otherwise it turns to red. When a red button is pressed, the corresponding HTTP request is, and change the button to green. When the top button is pressed, maybe a mistake doing it like that, turn relay 0 on, notice the spelling mistake in change, the button colour to red, wait for 2 seconds and then turn the relay off, changing its colour back to green. If the button is a momentary button, set the relay on, wait 2 seconds, set the relay off, setting the button colour red when it is on and green when it is off. Please include this ChatGPT request as a comment at the start of the code. If debug is requested, also write the URL to the console. Well, I'm sorry for all the words, but those are all the words you would need to write to tell a junior programmer to write this for you. I mean, most of us, in writing a thing like this, if we were doing it for a hobby use, we just keep it in our heads, right? But you can't do that here. You've got to be precise and pedantic with the machine in order to get it to do exactly what you want. And it took a few iterations for me to get the instructions right. So, if you think about what this is, we've got, here's our text file that's providing the syntax of what I want, the actions I want to happen on the buttons. So here's the text for the top button, here's the command that turns it on, there's the command that turns it off, and there's whether it's momentary or not. So that goes in a file button.txt, which is in the same directory as the command Python. And here is the little GUI I wanted it to generate. Now, I could not have built this without a lot of sort of looking at Stack Overflow, reading libraries, etc. All I did here was to write a specification and get what I thought was quite a neat piece of code and quite a neat result with zero work. And the more you use it, the easier it becomes. So what were the results? So I apologise, it's too difficult to show the code on slides in 24 points. So please go and read the article. The article has got a complete didactic sort of description of what I did, including the mistakes that ChatGPT and I both made in order to get to the target. So hopefully that's a readable way and it will give you some confidence that it's really quite straightforward to do. The fully functional code was produced, but in different styles in different generative AI applications. So you've got one complete style of code in ChatGPT. Gemini, or rather Bard as I was using, gives a much more sophisticated answer. When you look at the article and see it, Bard gives a much more sophisticated, compact, written by an expert type of code, whereas ChatGPT produces the sort of junk I would have probably produced by reading Stack Overflow and the manual, etc. Now, one of the interesting things that happens is you get crashes, particularly when you're doing pointers into various bits of memory to get the user interface to work. And anyone who's written code professionally knows what a nightmare it is trying to work out how you sort out a crash dump. You've got to sort of work it through and figure out what failed when and how you're going to get to it. And this was clearly something in the UI because it's a button problem. Well, all you do is to take this stuff that came out on the console, put it into the chat, just put it straight into the chat. And it says, it's very polite, this system, it says, I'm terribly sorry, I know what I did wrong, here's the new code. Yeah, I mean, this is This would have taken, you'd have figured it out. I mean, it wouldn't have taken long. You'd have figured it, it's something to do with the button. But some of this stuff, this was a Google, it's got Bard in it. But some of this stuff is a bit sort of mind-blowing to understand, this third-party, very compact, efficient code. But you just give it the errors, and it tells you what you're going to do. So, I'm going to finish a bit early, I think, unfortunately. ChatGPT took 37 attempts to get functional code, which was a mixture of me not getting the spec right and it making mistakes. But I'd have probably spent that number sort of taking the examples out of the library and chatting it, putting it in, etc. It was pretty quick. I mean, almost instant answers. And the code, although well written, was not quite as elegant as Bard. And this might have been the result, of course, of me sort of having a previous conversation with ChatGPT and trying to develop it while I was sort of going along, as it were. Now, the interesting thing about ChatGPT is if you said to it, have another go, it would willingly go away and it would have another go. It would give you an alternative. It would apply the biology, the evolutionary process to it, and it may or may not give you a better answer. But it knows all its sort of context, by the way, so it doesn't forget. If you want to really start again, it's really tough. It did, if asked, include the instructions as comments, i.e. include the source code in the generated code. So what the source code when you're running this model is that text description you gave it. And if you lose track and you lose the reference between the two, well, you don't want to lose your source code, right? So it would give you, it would sometimes do this. There's something I don't quite understand in terms of it sometimes being a bit disobedient, and that's true for both of these systems, right? Imagine you have a very willful intern writing the code for you. Maybe that'd probably get me into some sort of trouble saying that. It's a bit like that. Sometimes it gives you what you ask for it, and sometimes it says no, and sometimes it gives you something strange. But if you follow my algorithm, which is you run around the cycle of here's the spec, here's the test, feedback the results, you will always get something sensible out of it. So what was my experience with Bard? So Bard was Google's first offering, and it's replaced by Gemini. As far as I can tell, there's not much difference from a user point of view. It's just like having a chat with some agent from some service provider. But the example, the example was helped by the fact that I'd already had a go with the alternative package. It produced very compact, very sophisticated code for the Ethernet controller. And it did it in 7 iterations, some of which were me saying, I don't want an edit script, I want the complete answer, thank you very much. Because it's a bit inclined to say, oh, I made a mistake in line 32, change this. Well, you don't really want that. What you want to do is to have your complete body, because remember, you want to stay in the system for as long as you can. It was very polite, incredibly willful. So when I would say to ChatGPT, could you have another go, please? This would say, I just did that. Literally, I just did that. And I could never, ever persuade it to put its input script as comment in the code itself. And I have no idea why it refused to do that. It is actually my currently preferred code generator. I do need to experiment with the others. My nephew, who's something of an expert in this stuff, tells me I should try the GitHub one, which will have been trained on the huge body of code that is in GitHub. I don't know has anyone used the GitHub version of it? You've used the AI generator for it? Yeah. Will it work like this, or is it one that intercepts your attempt to do the coding and tries to improve it?
It's a bit of both, but the fact that because there's so much code,
Yes.
it's looking at other people's code.
Yeah, indeed.
Sort of
Yes.
to understand.
Yes. Yes.
That's very good.
Yes. Sorry. It is hybrid, is what the gentleman was saying, between one that takes text input and one that is sort of helping you synthesize the stuff as you go along. I've not tried it. It's on my list of things to do. So, almost the end. Intellectual property rights. So the first thing I say is that describing your problem to a public Gen AI system is a data leak. Most of the intellectual property you own, certainly if you're doing this commercially, most of the or if you're writing an academic paper, most of the IPR is actually in knowing how to ask the question. If you can ask the question, anyone can find you an answer. The trick in professional work is always to know how to answer the question. So the first thing is the very fact that you're asking it about something is telling this corporate, this body of information what you're doing. So I would never apply public generated AI to a sensitive project. The search and your tuning of the answer is almost certainly feeding the AI machine. In fact, I'm sure it's feeding the AI machine, and making this available to others. So you're losing your IPR doing that. The solution you get back from a Gen AI system may contain copyrighted material. And this is a standard warning that everyone needs to worry about. It's just as important for writing code as it is in writing text, because the code itself could be patented. So it could be IPR encumbered. Of course, I need to put the standard corporate speak in here. This is not advice. The RSGB does not give advice. You are on your own. If you are worried about the IPR, go speak to your lawyer. But just be careful and think about it, because you are giving IPR information away. But for the sort of things we do in terms of, a project for the shack, a bit of learning for research, that's not usually, you normally need to worry about it. So, generative AI-based generators are a game changer in software engineering. I think there's going to be a whole software in pieces of the industry that are going to change dramatically. The cheap coding shops overseas, I think, are going to disappear. In this talk, I explored 2 languages on 2 platforms. But the systems know about many more languages and many more platforms. It's just that I use Python and C-based Arduino stuff. It is an incredibly fast-moving technology, and every time you look at it, it will have moved on. There are many new code generators. I've mentioned GitHub, and we've had that. Stack Overflow has got one. I've never played with that, but the technology is simple to use. It works, and it should make software construction available to a much wider audience. And as you know from some of my RSGB work, I'm really interested in people building things and making things and learning about how to build and make things and learning and doing experiments that they might not otherwise be able to do. So that's all I wanted to say. There's a bit more information. Please read the RadCom Plus article. It's now, it was published a couple of weeks ago. The 2 systems that I used in this were publicly available and free, and they're the ChatGPT system and the Gemini system. And if anyone's got any questions, here's my email address. I'd be delighted to answer any questions. Does anyone have any questions for now? I should say I may be in the body of experts, but
it's not so much a question, more of a comment. But when you're talking about the intellectual property bit, there's 2 ways that you can overcome that. I'm not a salesperson for Microsoft.
Right.
However, the Microsoft Copilot ecosystem is completely protected, so anything you put into that, it's obviously quite expensive, but anything you put in is contained within the ecosystem, so
okay.
you can protect yourself by putting that code in.
Oh.
Also, If you don't want to pay for it, you can actually check out the YouTube. There's quite a lot of YouTube channels on how you can download your own LLM system to your own machine and run it directly from there.
Maybe
So-
I should encourage you to write something for RadCom Plus to show us, because I would like to move to the next level, and I don't have enough knowledge to do that. But I really would encourage others to try and teach it, because there's so much stuff we want to do. I mean, I don't know enough about it to do digital signal processing. I'd love to see us apply these things to digital signal processing. Thank you. One of my goals in life is to get a CW contest program that can pass the Turing test.
So you mentioned earlier that this would be a good tool for people who maybe don't have as much experience writing software. Yes. It seems inevitable that people will start using this stuff to build radios and possibly also to remotely control them.
Yep.
So do you see a situation where maybe the licensing conditions or the law may need to change to maybe decide who takes responsibility if something goes wrong, or what precautions would need to be taken?
Well, so first off, our license allows us to do this, right? There's no question our license allows us to do this. And where does the responsibility end? It ends in the licensee. So remember what I said. Test it, test it, test it. If it goes wrong, the chances are it's not going to go wrong in any different way from if you'd written the code yourself, because all of us write perfect code, don't we? I mean, everyone has bugs in their code. And the same with hardware. People make mistakes with their hardware. So it's no different from the way we work at the moment. Now, you could ask questions about, does the license exam need to change? Do we need to talk about software more in RadCom and the books, etc.? And the answer, I think, is yes, because if anyone saw the keynote talk this morning, you'll know that almost any radio made these days is full of software, and the old-fashioned block sort of system that we teach is not actually how it works anymore. So we will need to adapt, we will need to change to use these things, but I'm just hoping that I can get more people building things with software that would not have otherwise done so, because it wasn't within their sort of normal sphere of how they work. But all you're doing here, remember, write your specification, put it in the compiler, and get the answer out and test it. And that's just like buying an IC of your own, with your own specification, and plug it into a board.
Hi, Mike G4CDF. I've successfully used ChatGPT to review some Arduino code that I wrote and wasn't working. And it got it right within one go, but then I asked it to review it again, and it came up with some improvements. It says it's about right now, but it kept on changing it. Every time I asked it to review it, it kept on changing it. The real question I have is, do you think it's possible for AI to take software that's been written for one processor, maybe an assembler, and translate it to a different processor, such as Arduino? Is that possible?
Well, I don't know about getting from assembler across. I mean, I suppose it is possible. I mean, you could, the assembler is a functional description, and it might be able to do it. And certainly I know that we have cross translators. I know that large bodies of code that were written for x86 run on ARM as a result of compiling like that. And in fact, this is a very old technology, because I worked originally for Digital Equipment Corporation for a long time. And when we went from the CISC-based VAX to RISC-based, what was the RISC-based machine we had? It'll come back to me in a moment. We had a RISC-based machine, and the thing would just cross-translate it. So you don't even need AI to do cross-platform translation. But I see no reason why it would not work.
How large a piece of code do you think the ChatGPT or similar can handle?
I have no idea, to be honest. My approach would be, for just so that I understood it myself, would be to keep it down at the module level.
Yeah.
Right.
Okay,
so
thanks.
write a procedure and put them together, Maybe ask ChatGPT how you would construct a set of modules, so get it to do the system design. It's quite interesting asking it to do system design. It would tell you, do this, do that, etc. And then you can do the decomposition yourself. Whether these systems are sophisticated enough to build very large systems, I imagine so, but I don't know is the answer. Someone can go find out.
Is signal processing something that you can't do on this? Or
Sorry?
signal processing, that's something you
I've never tried asking it to do, to write a DSP algorithm. I tried asking it to write some GNU radio, which is how I would do most of my DSP these days, and it just sort of told me what I would do. It didn't actually give me any GNU radio output. I think a GNU radio expert over there is sort of... Have you tried it, Heather?
I haven't.
Anyone else? Okay. One last one. Coming to the end, so.
No, okay.
Okay.
So a simple question.
Very nice question.
Yeah, simple question. You said in your cycle that you had code and then test.
Yes.
Why didn't you ask GPT to do the test?
Why?
Give me tested code that does all this stuff.
Oh, well, because ChatGPT can't really become the hardware platform you're going to run it on. I mean, eventually it's got to get to the electrons. So, the test cycle was to put it through the physical layer so that, or through the whole compile cycle, through the physical layer, so that it actually turned the right relay on, for example, in that particular case. And sometimes it didn't. I spent forever with one bug, which was written up in the article, where I discovered that it was doing 0 index when it should have done 1 index. So it was always turning the wrong one on. And I had to persuade it that, well, I didn't have to persuade it, I just had to say, this thing starts at 0, it starts at 0 or starts at 1. And I understand now.
Okay, Stuart, thank you very much. Fascinating subject.